All right, ladies and gentlemen, welcome back from the break. You're in the Forge preview track, and we have an awesome talk coming up next on the journey to designing the Forge UI. So we have Jo originally from Design System, who's been working on she's a product manager on the Forge UI project. We also have Allard, who's one of our designers, also from Design System. So Design System at Atlassian is the team that puts together our design system, and also works on AtlasKit, which I'm sure a lot of you are consuming in your apps in the cloud. So a few months ago, we gave them the ambitious job of designing a extensibility declarative UI framework that would work in all sorts of Atlassian products, in all sorts of contexts, on all sorts of platforms. And they've done an amazing job at that. So they're going to be walking through a little bit of how they came to the Forge UI that you've seen in some of the sessions today. So take it away, Jo and Allard.
Hey, Allard.
Jo, what's up?
Have you heard?
What?
We finally get to build Forge UI.
We do? That's awesome.
I know, I'm so excited. I have so many ideas.
What? Tell me.
Okay, so I think it should be secure and have like 1,000 components from day one. You know what? It also should have all of the metrics, like who's using it, and when, and where, and how.
You know, I think those are all great ideas, but I think it should also be accessible and lightning fast. Yeah, definitely.
Yes. Fast. It should be super performant.
Yeah.
You know what? It should also have limitless configuration options.
Totally.
And be mobile optimized. Oh, and VR is a thing now. VR optimized.
Absolutely.
We should make this 100% future-proof.
Yes, the future. I can see it now. AI and machine learning. It'll be awesome. Wait, what if we had an app that could learn as it went? No, wait. What if we had an app that would write itself? No, wait. What if we had an app that made robots and that they did all the work for us? Now, that would be awesome. But you know what? All of a sudden, I'm realizing this is getting pretty complicated. On top of all of this, you know what it should really be? It should be easy to use.
So that was a little bit of a dramatized version of how we were feeling at the start of building Forge UI. We had so many ideas that we didn't know how we were going to set a concrete scope and figure out how we were going to build it.
And this can happen to any project at any scale. We bet it's even happened to one of yours at some point. Today, we're going to walk you through the exact journey that we took to build our first iteration of Forge UI. We'll highlight some of the learnings that we had so that maybe you can use them in your projects. We'll walk you through the goals that we set when we kicked off the project at the beginning, the research process that we went through, and then some of the design considerations that we had to make when bringing it all to life. And then lastly, we'll give you our learnings and have a brief look at what's next for Forge UI.
So before we dig into exactly how we built Forge UI, let's make sure that we're all on the same page about why we built Forge. From a product standpoint, we built Forge to make a better experience for our cloud ecosystem developers to extend the Atlassian products. Now, there were 3 key user pain points that we were hoping to improve. First, we wanted to provide a simple setup experience for developers by removing all complexities in setting up a cloud environment with introducing Atlassian hosting. Second, we wanted to ensure that Forge apps had built-in security. With our hosted infrastructure, developers will be able to create apps that have no egress of sensitive customer data at all. And lastly, we wanted to provide a simple app creation experience for our cloud developers. And this last point is what we're going to provide with Forge UI.
Forge UI is the UI framework of Forge, and it consists of a declarative component-based markup language that describes your app's interface, a mechanism for managing state and rendering that interface to a view, as well as a mechanism for then binding those UI controls back into your backing functions. For details of how this works, I would point you to Michael's and Simon's talk from before lunch. And for some examples of the code on how to write this, I would point you to Pete's talk from earlier this morning. The way that I like to think about it is that it's a UI pipeline. And in our talk today, we'll focus on the design aspects of the output of this pipeline. As Joel mentioned earlier this morning, one of the main motivators for Forge is to let the app developer move up the stack with more abstraction. From a design standpoint, we wanted to introduce similar abstractions, giving you as much design support as possible to help you bring your ideas to life quicker. So we wanted it to be cross-platform without any extra effort to you. You build it once, and you can see it everywhere. We also wanted to have a low barrier to entry with a fast iteration speed. This would mean that you should be able to build UI quickly without worrying about the details, which meant that we also have to have the best UX out of the box. Best practices and accessibility should be baked in, all whilst the apps fit seamlessly into the products. So these are all lofty goals, and we needed to narrow them down to create scope. For instance, we still hadn't decided who we were going to build this for. Of course, we want it to be for everyone, but we needed to focus on someone to start. So who had the most to gain? We decided to start with the in-house dev. The in-house developer is a persona that we established. They may be a software engineer or a sysadmin day-to-day, or they may just be a tech-savvy PM. But the thing that binds them is that they don't code extensions as their day job. Rather, they do it as a side job. They've been tasked with writing all the tools to fulfill their team's workflows, needs, and requests, if being so willingly or not. But what they want is to solve problems quickly, and they're often limited by their knowledge of the cloud platform and how it works. So to think of it in another way, if our current offering is for unicorns, an engineer or a team of engineers that can do all the things, design, write code, deploy, monitor, and maintain, our current offering is more for the corns. It's so simple that you don't need all that knowledge because the platform has done all the unifying for you. From understanding our persona and their needs, we also landed on using a declarative UI, rather than an imperative one, which we can see on the left-hand side here, where you need to construct the UI and handle all of its mutations. A declarative UI just simply describes the UI, and the platform can take care of all of the interactions that it might have. This helps our in-house dev persona because it's easier to compose. You only need to say what you want, and Forge will take care of the how. It also allows for the encapsulation of design and UX choices, all resulting in less code and less effort for you, allowing you to focus on business value and creating experiences. And of course, we now need to decide where those experiences go. Where should we start extending? Well, we decided to start with Editor for a few reasons. First off, Editor is already cross-platform. It's one of the biggest platform pieces that we have existing in Confluence, Jira, and Bitbucket, amongst others. It also already has a rich history of customization. People have been building macros for a while now, and users are very familiar with using macros in their Confluence experience to extend their workflows. It's a powerful and versatile starting point because it has many, many use cases and thus many opportunities for customization.
So now that we understand the problems that we wanted to solve for with Forge UI and the goals that we set for extending the Atlassian editor, how did we actually get to understanding what types of editor macros that our users wanted to build and the components that we would need to provide for them to build these macros? Well, the Forge UI team was put together very quickly and from different teams across Atlassian. We brought in people from the editor team, the Alice Kit team, and the front-end platform team. And while this meant that we had some cracker talent, it also meant from day one, we had a lot of unknowns. So our first step was research. Due to the fast-paced nature of our project, our research journey was a pretty scrappy process. And it simply started off with Allard and I sitting down to define a research plan. So the goal of our research plan was to collate and summarize all of the disparate pieces of research done across Atlassian. At the end of our research, we wanted to understand three things. Firstly, who is our target persona? what are their goals and the problems that they're facing? Second, what types of editor extensions do these in-house developers want to build? And then finally, what components do we need to provide for these people for them to build these macros? Now, we started to talk to subject matter experts from different teams across Atlassian's to talk through the research that had already been done on these topics. Here, we gleaned some key insights into the in-house developers that Allard went through earlier, and this led us to some key decisions, such as building with a declarative UI. But we also realized that there actually wasn't sufficient research done on what use cases these in-house developers wanted to solve for, and the types of components that we were going to need to provide for them. So the next step was to set out and understand what types of editor extensions our users may want to build with Forge. To do this, we did 3 things. First, we started close to home by asking internal Atlassians, what types of editor macros would you want to build? And we did this through a Confluence question. So at Atlassian, we use Confluence internally as our main source of communication. So it's a natural place for us to pose this question to all of our internal devs. Second, we posed a similar question to our external developer community by posting on community.atlassian.com. And then finally, we did an audit of editor apps on the marketplace for both cloud and server to see what kinds of apps existed today, what use cases users were already building for, and if any gaps existed between cloud and server. So from that internal Confluence question, our external community post, and our marketplace audit, we started to identify some trends in the types of macros that we were seeing. We were able to then piece together these trends and create a list of editor apps with diverse use cases and experiences. So some of the most popular use cases that we saw were extensions such as poll macros, sign-up macros, and table macros. Now, once we identified a variety of use cases that users may want to build apps for, it brought us one step closer to understanding the scope of Forge UI. Now equipped with our diverse macro list, we were then able to set out to understand the components that we would need to provide to support these types of macros. We wanted to do this in a way that was based on user research and not just gut feel. And to do this, we ran 2 workshops with the goal of getting to a validated list of components that we would build for our first iteration of Forge UI. So the first workshop that we ran was a component brainstorming workshop, where we took that list of diverse macros from the previous step, and we determined how our users may go about building them. To do this, we ran a design exercise called Crazy Eights. So to run Crazy Eights, all you have to do is fold a piece of A3 paper into 8 sections. And then with a Sharpie, you have to try and fill all 8 panels. But you just have to do it in 8 minutes. So the result is a storyboard of your solution idea. And because it's so quick, you can repeat this exercise to come up with a breadth of solutions in a short time frame. So this was a great exercise for our first workshop, where we were trying to understand the many different ways that our users could build the macros from our list. We ran this exercise 4 times with the top 4 extensions, and then in our shareback, where we went around the room and we showcased our solutions, we talked about the different ways that we could build the same macros with a variety of different components. After the workshop, Allard and I then looked at all of the solutions and we tallied up each component that was used so that we could understand what the most frequently used components were. From this, we were able to determine a list of top 20 components that we saw. And in preparation for the next workshop, Allard quickly drew up this list of components, and this actually became our first version of the Forge component list. As you can see, it's pretty scrappy. It was just hand-drawn on a piece of paper, and the low fidelity was actually done on purpose, as making hi-fi mocks wouldn't have provided us with any further value at this stage. Before we could plan out our scope and our execution, we first wanted to validate the component list. we needed to see if the top macros that we defined before were able to be built with just these 20 components. And to do this, we ran our second workshop, the component validation workshop. So now, armed with our component list, we asked our developers to build the same macros as the first workshop, but this time with the limitation of using only the components on the list. In the shareback, we focused on talking through any of the limitations that we came across from using this set of components, and then this allowed us to further refine our top components list. From this session, we had a newly edited and validated component list, which was now rigorous enough to support a variety of editor use cases. Now, our hypothesis here was that if these macros from our diverse macros list could be built with the components from our top components list, then most of the other macros that our users wanted to build could be built in some shape or form using these macros. So one interesting thing that did come to light during this workshop was that not only did we have to provide a set of components for our users, we also needed to define a layout model so that the app developer didn't have to think about this themselves. And Allard's going to dig into this a little bit later. So at the end of this process, we had gotten a diverse list of macros that detailed different use cases of editor extensions and a validated list of top components that would support the building of these macros. So from here, what we needed to understand was how are we going to ship these components and these macros? We wanted to get feedback as soon as possible, so we didn't want to ship a big bang release where users would only be able to build macros once all the components were shipped. Instead, we wanted to define a gradual and iterative release where users could gradually build macros as we gradually release components. Now, to define this process, we sat down and we looked at that component list. We asked ourselves, if we had to group these, how would we go about doing so? Well, the first thing that we would need to do is to identify the minimal working set. What's the most basic functionality a macro can provide and still be valuable? We were literally defining the MVP of a macro. And we define this MVP as render-only macros. And these would be macros that just displayed information. So if we were to take an example, think of a GIF app that simply loaded a new GIF from the Giphy endpoint every time the page was loaded. Now, this would be a render-only macro, as it only displays information. The next level of macros that we could abstract were called actionable macros. Now, these would be macros that users can now interact with and then cause a re-rendering of the macro. So for example, if we take that render-only GIF macro example from before, and we were able to make it actionable, we could now add a shuffle button that, when pressed, would load a new random GIF. The last level of macros that we could define were configurable macros. So these would be macros that users could not only interact with, but also configure. So again, if we take the GIF macro example, we can now introduce a configuration setting where the user can define a search term, let's say the metal age, and now the macro will just load GIFs related to your favorite metal band. Let's look at this GIF a little bit closer.
That's amazing. That's my favorite band.
I know, I just can't wait for their next album to drop.
That's so cool.
So back to where we were with our macro levels. We called these our macro richness levels, and this allowed us to think of building macros and components iteratively. Once we had our macro richness levels, we then took our original list of diverse macros that we used in the first 2 workshops, and we were able to fit them into each of these levels. We also realized that these macros would make for great reference documentation, so we renamed this list to our reference macros list. So once we had our validated component list, our macro richness levels, and our list of reference macros, the order in which we'd iteratively deliver our project came out quite naturally. With this, we wrapped up the research portion of our project and we moved into execution.
So we had an app list, we had a component list, and we had an order to build things in. You'd think the hard stuff would be done. Remember those amazing sketches that we had for the second workshop? It would be great if we could just hand those over to the engineers and be done with it. But no, we still had some hard questions in front of us. For instance, on top of actually designing the components, figuring out how we wanted them to behave, we needed to have some guidance on how to make trade-offs while designing them. We needed to have some design principles. And on top of that, as Joe already mentioned, we still hadn't figured out how to deal with layout. So let's dig into some of the design considerations that we made whilst figuring all that out. It can be difficult to make trade-offs and figure out which design is better when comparing two different designs, especially if you haven't actually agreed upon what you're going to optimize for. Design principles are a great tool to help you do that. Design principles help guide your choices by forcing you to optimize for a goal that you set. And the best way to define your design principles is to take the goals of your user, of your personas, and the goals of your business, and to make a choice about which trade-offs you are willing to make and which you aren't, and ultimately, which things trump which at what point in time. We felt that for Forge UI, we had a bit of a blank canvas, so we needed a few more constraints. We started looking into principles. Luckily at Atlassian, we already have an awesome set of design principles that are global for the whole company. They talk about building trust in every interaction, connecting people to collaborate better, match purpose and feel familiar, driving momentum from end to end, and guiding mastery for greater value. I won't dig into the details of those here, but if you're interested, you can find them on our design site, which is at www.atlassian.design. There's a lot more explanation about how we want to make these principles come to life. These were good for the global design at Atlassian, but we felt that the Forge UI persona was still a slight subset of that. So we wanted to have something specific for us as well. So we extended those 5 with 2 principles that we came up for ourselves. The first one is to design for ease and speed over flexibility. We wanted things to be composable, we wanted things to be flexible, but never to the expense of things being simple, easy, and lightning fast. Which meant that we wanted to have as many smart defaults as possible and abstract away as many sensible options as we could so that stuff just works. The second principle was that we wanted Forge UI components to provide direction. Forge UI components are not atomic. For instance, it's not just an icon. If you had an icon, you would have to deal with positioning and coloring and a lot of minutia, and we didn't want the app developer to have to deal with all that. Rather, we wanted Forge UI components to be already composed molecules. Each Forge component is an intentional solution for a particular use case. A good example of this is that if you have a text input in a form, the input component is not just the actual text input, but comes with a label and with a place for validation text, all built in. These principles helped guide all of the next steps that we took. You may remember that Joe mentioned in our second workshop, we bumped into problems with layout. And because we were working with a declarative language, as designers, we wanted to abstract that away as well, as much as we could. And we ended up with 2 concepts, blocks and containers. First, let's deal with blocks. This came about pretty simply, actually. When we started with our level 1 richness macros, remember, the level 1 richness are the types of macros that can only render data and you can't interact with it. We thought, what happens if we just chuck all the components onto a page? How would that work? Would it break? Turns out, if you put everything underneath each other, it actually works pretty well. You end up getting this vertical stack with some kind of slots. And we came up with the idea that every Forge UI component could be a block. This would allow us to play with its size depending on the container that it appeared in. This actually gave us quite a few benefits. For instance, it gave us responsiveness because we could reflow the inside of the layout of a block. Depending on a container's width, we could have responsive behavior inside of it. And this was really useful because Confluence itself, for instance, has many column layouts and even different page width layouts. And then in various applications, the editor itself will show up in different sizes as well. All in all, that gives us over 20 different widths that an actual macro can show up in, and then the components inside of that as well. It also gave us a cross-platform compatibility, because not only were we able to reflow layout within a block component, but we could actually swap in and out different UI elements within that block if we so choose. For instance, on mobile, we could still render the blocks in the same order. The vertical stack would stay the same, but we could choose to render bigger buttons on a mobile platform because you need a bigger touch target than we would on web. And the app developer would still just define button, not caring about what it actually looked like. So this really fit with our persona of the in-house devs because it abstracted away layout choices, which makes it easier for them to define things. And it actually gives us more control over the experience, making the UI more robust across all the places that it shows. This is really the design principle of ease over flexibility at work. Now, this was all well and dandy until we started looking at interactive apps, and then we hit a bit of a bump. We had already started having discussions that a table wasn't really a block because it contained other blocks, but this became even more evident when we started looking at forms. And with forms, you need to be able to group things. So we needed to revisit our layout model a bit. To understand why you need to group things with a form, let's have a look at the following example. Imagine you've built a macro that asks for travel details. And we start with asking a first name and a last name and a submit button for the first traveler. So far, so good. You hit the submit button, it submits the two inputs. And then we have a second form where we ask for the name of the second traveler with another submit button. But how would this really work? Either button wouldn't know which inputs to submit. We could say that the whole app or the whole macro should be a form, but then we wouldn't be able to distinguish between the separate names unless the app developer was very diligent about naming everything correctly and they came up with their own concept of that. We needed to wrap those inputs into separate parts, giving the developer more control and also making it easier, abstracting away those complexities of how to deal with that. We've identified a few more containers so far. On top of forms, there's table now, elevated to a container, and button set as well. To be honest, this model is still the least clear part of our work, and it's our working hypothesis. So I have a request to you as an audience. If you can come up with use cases where you could break this model or where you'd want to extend out of it, come chat with us afterwards because we'd be really keen to hear more about that. So where's this component list already? We've been talking about it for ages and you still haven't seen it. Well, I'm going to show it to you now, and it's a nice focus list that we feel you can build the majority of your app use cases with. There's containers and there's blocks. Containers are a button set, a table, and a form, and blocks are everything else. Buttons for interaction, text and image for displaying data, text fields, text areas, radio selects, and a date picker for form inputs. We're still looking to add more things like a media card and a user picker. And we'd be keen to hear your input on other components that we should add as well. Now, this list might seem simple and short, but it is powerful. It's really been curated by our design principles and is the design principles at work. For instance, for ease and speed, all of the blocks have responsive behavior built in. Images auto-resize, and forms also take on a different size depending on where they get displayed. All of the components also provide direction. This is most evident with form fields, where an input field will come with a label and a description and a placeholder text as things that are built in. But form submission also comes with form validation built in. So all you need to do is write a validation function, and it will just work. We found that there is beauty in this simplicity, and it can actually already provide for some outlandish use cases. Here's some of the examples that we've built internally. Here's Nick's app. Nick is the feature lead on Forge UI, and he DJs every Friday after work on our floor. And when I say DJs, I mean that he basically puts on a Spotify playlist and turns up his speakers really loud. Now, because the teams, because all of our team have a different taste in what they think is good music, there's often quite a bit of discussion about what the next song should be. Now, so Nick wrote this app that allows you to like the song or to skip forward, and it connects to the Spotify API to actually do that. But you're only allowed 2 skips, so you better use them wisely. And then there's another example. Here's a 2048 game built by Peter, one of our engineers. For those who don't know the 2048 game, it's a tile shuffling game where when 2 numbers that are the same appear next to each other, they get added together until at some point you have a single tile that is 2,048 points. What's exciting about this is that he built it with just 4 buttons, a table, and some images in less than half a day, where most of his time was spent trying to reverse engineer how 2048 actually worked. This might seem like a frivolous case, but we can easily extrapolate from here to a more serious case. For instance, if you had a row of table cells where you're adding up all the numbers to aggregate them in the final cell.
So it's really exciting for us to see all of these cool new apps being built, especially after all of the work that we went through on our journey. So now that we've come this far, what did we actually learn from all this?
Well, I think one learning that I had was that if you need clarity, you should go back to the basics. For instance, at the beginning of the whole process, we were kind of spinning our wheels, we had all the crazy ideas, and we didn't really have direction. And focusing on our users, defining a persona, defining their goals, really helped us get clarity on that. So if you feel lost in your project, perhaps it's because something that is a bit more fundamental to the level that you're working on now hasn't been defined yet. Go back to basics, and that might help you get clarity.
A key takeaway that I had was that you need to accept that every project is always going to have its unknowns. It's not always feasible to spend weeks up front doing all of your research. So keep it lo-fi when you can and continuously learn as you go.
And the last one for me was really an underscoring of something that I already knew deep down, but that workshopping and group work are really instrumental to a large project like this. When someone went off as a single person to solve a problem, they ultimately got stuck. I never did this, by the way. I always collaborated really well as the only designer on the team. Never got stuck on anything. But they would always get stuck, or they would have a solution that, when it was proposed to the team, would always get picked apart in the end. Whereas if we came together as a team and we hustled, and then we came to that solution together, we would always have something that was more robust. So our takeaway is, if you're stuck, try to find people to collaborate with and try to get feedback from them. Not only will it validate your idea more quickly and make it more robust, but you might even get an idea that you didn't have before on your own.
So it's been a bit of a long journey, hasn't it, Allard?
Yeah, it's been an exciting ride, to say the least.
We've come a long way in our story from being that little bit overwhelmed we were in the start with all of our big ideas.
Remember, it has to be easy to use.
And hopefully we've achieved this goal. We'd love to hear all of your feedback on our progress so far on Forge UI, so please come over to the labs if you haven't so far and check it out.
And if you can't make it to the labs, then please keep an eye on our Forge Beta program, which is coming up. In the beta, we'll have continued our journey on making Forge UI the best extensibility experience for you, and we can't wait for you to try it.
And maybe by then, Allard, we'll actually have those robots doing the work for us.
Oh yeah, that would be really awesome.
Thanks, guys. Can I stay here or go?
Thank you so much, Allard and Joe, for an awesome presentation and my cameo. Maybe before I commit to dancing on stage next time, I'll remember that cameras exist. But I think we've got 5 minutes left if anyone has any questions. Fantastic.
I'm just going to grab some water.
Okay.
Hey, thanks for that talk. We saw today that there's a possibility that an editor may turn up in the UI, but then my question is, the editor is probably going to generate ADF, and does ADF then become like a competition to the UI that you've developed?
So the idea of the editor showing up in Forge UI would really be another extension point. So right now we focused on extending the editor itself, but we can also imagine that at some point, and that's not where we've started now, at some point we will extend other parts of our products, and you would actually need to place an editor there. So in that sense, there will likely be different places where some components might work and other components don't work in that way. Yeah.
Any other questions?
We made sure it was accessible, Marta.
Yeah, great. I'm not worried. So in the future, some of our apps have a very small space to work with, and our users want to see a lot of data. Do you think we can will there be a future where there's more options for granularity, maybe? Instead of putting everything in blocks vertically, maybe also, something horizontal or?
Yeah, that's a good question. Like we said, we're still on this journey, so we're still trying to figure out how these components will behave when placed in something that is a bit more narrow, so say Jira Glances or in mobile view. We are trying to make it so that we can abstract a lot of those complexities out for you so that it will automatically resize. So if you place a date picker in an editor app, it might look different if you place it in the Jira Glances. Do you have anything else to add?
Yeah. To answer your question about is there a future where that might happen, it might. We'll need to explore it, and we're on our way there. We need to find that balance of how much granularity we want to give. Like I said, with our design principles that we've settled on now, how much granularity do you want to give at like the no expense of like trying to keep it simple and fast. Yeah.
But having said that, I think we actually want to hear from all of you guys about what kind of granularity in terms of configuration you're looking for. So if you guys have any ideas of what you'd like to see, please come chat to us.
Absolutely. Yep.
Thanks.
All right, we probably have time for one more question if there's one out there.
Continuing on that same granularity, would you agree that, now that you have some kind of, like, I'd say HTML, that eventually some kind of style sheet on top of that is inevitable?
So I can jump in on that. Our current vision is that it fits in with the product seamlessly. In other words, we would want it to be ADG compliant. And in that sense, there is little extra stylistic room that we would want to grant outside of the stylistic room that Atlas Kit provides itself, or Mobile Kit for mobile. There's little that we would probably want to step out beyond that.
But again, we're still trying to understand all the different use cases. So if you have specific examples you can share with us, please do, because we're very curious about how you might be able to use that to your own app.
Thank you.
It's an interesting point as well, and I think theming in general is probably something that might span out beyond the individual apps, if that's something that you might be interested in. But I think there are some active discussions in that area at the moment in cloud. Cool. Alrighty. Thank you again very much for the presentation, Joe and Allard.
Thank you for coming.